Bismillahirrahmanirrahim. In the name of Almighty Allah, who is the most beneficent, most merciful, most gracious, and the source of all knowledge. My name is Engineer Zainul Abidin, and I would like to warm welcome to all of you by saying the Islamic greetings. Assalamu alaikum rahmatullahi wa barakatuh. Hope so you all are safe and sound at your home and must be enjoying the holy months of Ramadan. In our previous lecture of physics, we have discussed something about what is the energy and what are the different forms of energy, and also we have seen what is the difference between the potential energy and the kinetic energy, and what are the different forms of the potential energy like gravitational potential energy, elastic potential energy, etc. In our today's lecture, we will discuss about the law of conservation of energy. This law was actually put forward by the scientist named as the Lavoisier. According to his theory, energy, there is a specific amount of energy that has been transferred by the Almighty Allah in this world. Okay, not only energy, it is about all the matter that is in the whole universe. A specific amount of all the matter, whether it is in the form of water, in the form of soil, in the form of energy or any kind, specific amount has been transferred by the Almighty. And according to his theory, this matter or this energy can neither be created or nor be destroyed, but it can be converted from one form to another form. Okay, repeating it again, energy can neither be created nor be destroyed, but can be converted from one form to the another form. In your book, at page 85 and page 86, there are conversion of energies from one form to another form. As you can see, a cyclist is driving a cycle. That means he is converting his mechanical energy into the motion of the cycle. Therefore, this is the conversion of energy. And also, if a cup that is lying at a specific height and it's fall down and breaks, so the whole energy that is actually due to the gravitational potential energy is converted in breaking, in sound energy, in heat energy, and the breaking into the pieces. Okay, so these are the conversion of energies from one form to another form. So this energy transformation actually results the energy input that is actually equals to the useful work and the waste of energy. Okay, so this equation is actually telling about the efficiency, the whole energy input that is equal to the useful work and the waste energy. For an ideal system, the output is always equal to the input. Ideal system means the system in which there is no resistance, there is no air resistance, and there is no friction. Okay, if you are giving the 100 joule of energy to a system, then you are getting the 100 joule in the form of output. Okay, it does not matter it is input or output, it is always equal to the 100 if you have provided the 100 joule. But practically, if you are giving the 100 joule of energy to a machine, then it will pay back to you about the 50 or the 70 joule, which is not equal to the 100 joule. That means the remaining 50 joule or the 30 joule energy has been transferred into the waste energy. So this is about the efficiency. So according to the definition of efficiency, the efficiency is the ratio of the output to the input given to the system, and it is measured in percentage, and it can never be 100% for a practical system, but for an ideal system it can be 100%. So here we have the formula for the efficiency, which is equal to output over input, and when you multiply it with the 100%, then your answer will be the percentage efficiency. Suppose we are given with the 100 joule of energy as the input, and we have paid back by the system is about 50 joule. Okay, this 100 joule is input, and this 50 joule is output. So our efficiency, this is the symbol that is used for the efficiency, which will be equal to 50, that is our output, over input, that is 100. This is cancelled, and 5 ones are 5 twos are 0.5 multiplied by 100%, so 50% will be our efficiency. Okay, it is actually showing you efficiency can neither be 100% for any system. There must be some resistive forces, or there must be some frictional forces that will reduce the work or the output of the system. Regarding to the efficiency, there is a concept of the power. According to the definition, the rate of work done or energy converted. The formula for the power is actually W over T. As I have told you in our previous lecture, the verb rate means we are dealing or we are discussing related to the time. So the power actually defines you the rate of doing work. Okay, as the energy is the ability to do work, but the power is the rate of doing work. Okay, this work is actually equal to energy. As I have discussed something about the work, and unit for the work is 1 joule or 1 newton meter. This work includes different kinds or different types of energy. Okay, different forms of energy. Two of them has been discussed in our previous lectures, that are the kinetic energy and the potential energy. So regarding the kinetic energy and potential energy, you can write the formula of power. P is equal to W over T, that is equal to E over T. If you are dealing with the potential energy, then your formula will be mgh over T. Okay, your formula will be in this form. And if you are dealing with the kinetic energy, then your formula P is equal to E over T. And if there is the kinetic energy, then this will be 1 over 2 mv square over T. So this will be the formation of your formula if you are dealing with the kinetic energy. So in general formula, P is equal to W over T, where P is the power, W is the work done, T is the time which is measured in second, and the work done is measured in Newton meter or joule, and the overall unit for the power will be joule per second, or you can say the joule per second is equal to 1 watt. Okay, here our syllabus ends. If you have any kind of question related to our today's lecture, you can ask me. I am there for you. Thank you very much.